Hi everyone, geophysicist Stefan Burns here with a pretty serious announcement. We have a very unusual anomalous signal that has been detected in Earth's natural energy field. We have seen these sort of anomalous signals before. That's one of the things that we track together on this channel. And every time that we've seen this anomalous signal in a significant way, and even times when it's just kind of a whisper, we have seen very high magnitude earthquakes occur shortly afterwards, just within days. So this is some of the craziest the parameters that we've seen on this signal yet, at least with my experience, my time observing this. A great example that we'll go into, we're going to go through all the historic examples so you can really make up your own mind and opinion about what this geo alert means. We hope that nothing happens from this. Let me state right from the beginning that there is no guarantee that there's going to be some sort of big one. Typically, these sort of anomalous signals are linked to earthquakes, high magnitude earthquakes. There's no guarantee that happens. I'm not hoping for that. No one wants that. We are, though, looking at this just from a very realistic standpoint because we see these connections. The most poignant example was back on February 2nd, 2023, 4 days before the magnitude 7.8 and 7.5 earthquakes in Turkey near the Syrian border, which was devastating. I have friends in that area that were absolutely devastated by those earthquakes. We saw anomalous signals in the Schumann resonances, again, 4 days before, and then the day of, starting exactly when that earthquake occurred, we saw a 6 to 8 hour long anomalous signal appear very obviously. That was correlated perfectly. We've also seen these signals before the most recent seismic burst at Camp Eagle, which is around February 17th with a few days on each side. That was this year. We saw these signals appear back on November 29th. That was 5 or 6 days before the magnitude 7 earthquake that occurred off the coast of California to the north near Pretoria at the Triple Junction. We saw these signals also occur back on February 22nd, 2024, and about 24 hours later, we had a magnitude 6.3 earthquake, which was the only magnitude 6 plus earthquake that occurred for like a week on either side. So it seems very much linked to that. And then just recently, we also, just like 2 days ago, we saw some of these pre-earthquake signals in the record, and they were very faint and quiet, and we had that magnitude 7.4 earthquake that hit south of Chile and Argentina within about 24 hours, actually less than 12 hours, I believe, after that occurred. And that was measured about 18,000 kilometers away. So that would explain why the signals showed up so faintly, but we did observe them. I have a keen eye for this. I track this stuff every day, folks. This is really my passion, my interest is understanding macro Earth geophysics. That's what I educate on this channel. So if you like to stay appraised with these Earth changes, then you can subscribe to the channel. I release videos almost daily. But this is a pretty serious thing. So let's get right into the data. And we're going to then go to through the historic examples, and then we're going to go back to the data so we can better understand it once more. But let's go straight into just what we're seeing because it is very, very anomalous and bizarre. Actually, let's start here with our spectrogram. Here we have a spectrogram of data from the Space Observing System. This is a public geophysical observatory out of Tomsk, Russia. It's run by the technical university there, and they take measurements on the ionosphere. They take measurements on the Schumann resonances. They take measurements also just as it relates to solar activity and such, and they post that on their website. And they seem to have one of the best public observatories as it relates to capturing high resolution data on the Schumann resonances. Here we see definitely an anomalous signal there, and that is right in the pre-earthquake signal range of about 20 to 25 hertz. So it's more like 15 to 30 plus hertz. But that was the first kind of clue that something weird was happening for this most recent burst. And I noticed that, but we had something really critical occur here, and actually now the data is offline. If we go back to the 1st of May, we see our anomalous signals. They're very faint, but see that line right there? That's one. We see some more right here, like this. We also see a little parabola there, a little bit of like anomalous energy bleeding there. We see this increase in the intensity in the very low frequencies right there. That's about 5.5 hertz. This is 0 hertz up top, 40 hertz down below. I'll explain this more later, but I just want to get your eyes on this right away. And then there's also just in general some weird energy kind of signals all throughout this part of the record right there. Then about, again, less than 24 hours later, magnitude 7.4 earthquake in Argentina and Chile, just south, the very southern tip of South America. I reported on that in a live stream about 10 hours before that earthquake occurred. Now the data has actually gone offline because for Tomsk, Russia, it's actually already May 4th and it's early morning there, local time. This is all universal time +7, so you can convert for your local time zone, but they have not updated the data. So we see that actually now we are behind. But if we look at the most recent, they have 4 parameters that they measure. We have the spectrogram, which gives us a look at the intensity of the vertical electric field going from 0 to 40 hertz across time. We use these colors to denote intensity. Indigo and blue is low intensity, red and white is high intensity. But there are other measures as well. For example, we have the amplitude measurements. We have the frequency measurements for the first 4 modes of the Schumann resonance, 8 hertz, 14 hertz, 20 hertz, 26 hertz. We also have the quality measurements, and this is the specific data signal that really tells you that something may be coming. And let me explain why. So you have what's known as resonance amplification. And this is very simple. When you have something that's resonating, it's going to keep resonating so long as it's being fed energy, right? If you hit a church bell, let's say you give a church bell a good old hit, it's going to let out a beautiful note, it's going to ring, but eventually that'll fade out. But if there's something that's continuously hitting that, it's going to keep on vibrating. Resonance. Now you could, and people have done this before, and there's metronomes and things that you can do this with, you can hit things that are tuned to the same note, the same resonant frequency. You can hit one and the energy will move over to the other and they'll both start to vibrate. If you have a lot of dampening in the system, this is the specific term they use in physics. If you have a lot of dampening, then you can hit something, but it'll quickly go back to baseline because the energy dampens out. Whereas if you have very little dampening, then the thing can keep ringing and vibrating for a very long time before it dampens out. And that is actually what creates the Schumann resonances in the first place, is that we have all these lightning strikes around the globe that are constantly feeding energy into these extremely low frequency fields, going from about 5 to 50 hertz. And the overall attenuation on these signals, the dampening is very, very low. And so they continue to resonate all the time, globally, without fail. They've done it, we think, for millions and millions of years, basically because we know that they had this as a result of the global electric circuit in the ionosphere and charged particles hitting our magnetic field, driving this global electric circuit, which we've had that since basically the Earth was generated and created in the beginning accretion or whatever. So these are constantly vibrating. Well, if we go back, when you have all of a sudden more energy in that resonant system and the energy that's leaving the system does not increase, or actually it even perhaps diminishes even further, then you have resonance amplification and the energy can build and build and build, and that is actually a mechanism that can cause really destructive damage. That's what causes buildings to collapse during earthquakes. If the building is at the resonant frequency of some of the seismic waves, specifically usually the surface waves, then it causes the building to go like this and eventually collapses. That's what caused the collapse of the Tacoma Narrows Bridge in Washington. The wind was at the right resonant frequency of that bridge. They call the bridge Galloping Gertie. And eventually the wind was so strong going through that pass that it caused the bridge to collapse. That's resonance amplification. If you've ever, I'm sure everyone's done this. They found like a tree and you push on it, you're trying to find that frequency at the tree, and you get to start to sway because you're timing how you're pushing on it. That's resonance amplification. The energy keeps going in, but it's not dissipating out. Okay, quality factor measures that phenomena. It measures resonance amplification. Normal values for these quality factors that we're seeing here for the data that we just looked at. Again, if I go back one more time, for this data on the vertical electric field going from 0 to 40 hertz, which shows the Schumann resonances, mode 1 there, mode 2, mode 3, mode 4, mode 5, mode 6. These natural wavelengths of light that form standing waves created by the global electric circuit. They've guided our evolution across time. They connect to earthquakes, they connect to space weather, they connect to local atmospheric disturbances like thunderstorms and more. They normally have a quality factor of about 5 to 15. That's the normal value. Here, we see the quality factor for mode 1 go up to 190. We see the quality factor for mode 2, 320. For mode 3 at 20 hertz, 460, and mode 4 at 25, 26 hertz, which is that frequency range that's connected most strongly to pre-earthquake signals. That's what our observational research is telling us. That has a quality factor here of 590 before the station went offline. And this breakdown of the quality factor is going up even more for the higher modes also makes sense as it relates to a pre-earthquake signal. Because again, we typically see the strongest changes in the Schumann resonances before an earthquakes around 20 to 30 hertz, which would go from mode 3 all the way through mode 4. Now, this is just a temporary little blip. So I do want to state fairly close to the beginning of this live stream, because we're 12 minutes into it right now, that this could just be a data error, all right? We had this go offline. We're not seeing anything super dramatic happen at the moment that it shifted, but again, it was like the moment it clicked up, boom, it went offline. This could be an error. We see that the amplitudes for some reason went down, and we do see, is this the amplitudes? Yeah, and then we do see that the frequencies also that they're measuring started to go down. We're measuring the peak power frequency here. So if you go back again to here, we see that the Schumann resonances kind of make a range. You know, there's a band to that increased intensity at that frequency zone of about 7.2 to 8.8 hertz for mode 1, for example, but there's a peak power frequency. There's a frequency within that band that has the most power within it. That's what we measure here. We see that that also started to decrease suddenly, rapidly, right as then the station went offline. Because again, now it's actually May 4th, early morning for Tomsk, Russia, and this is only showing up to May 3rd, about 2000 local time, UTC +7. But it doesn't seem that that's the most likely scenario. Or at least, you know, we discussed the possibility that this could just be some data malfunction, but we've seen this observation station go offline before. People just call them sometimes blackouts. And just in general, when you have geophysical equipment, monitoring stations, sometimes the data just drops out because the equipment goes offline and you need to recalibrate it or things of this nature. We'll talk about this more later, but that's just a normal thing. Sometimes your computer freezes. You have to restart your computer, right? Things like that. So it's not impossible for this station to go offline. It's done that before, but we've never seen this happen before while it's gone offline. At least in all the years that I've been watching this, I've never seen it behave like this before a blackout. It's always just basically normal data coming in and then it just goes dark. So this looks like resonance amplification actually potentially took it offline. That the energy signal that it received was so strong that it completely overloaded the system and caused it to crash. Now, if we go over to our data out of Cumiana, Italy, we have another publicly available Schumann resonances monitoring station here. And this is maintained by VLF.IT, the guy who runs the website, Renato Romero. And he basically has this antenna strung up in his yard there, a T antenna, the same type of antenna that they also use for the space observing system in Tomsk, Russia, to measure these extremely low frequency vibrations in the vertical electric field. So we have our VLF data here. This is going from 0 to 1500 hertz. Then up top we have 0 to 15,000 hertz. This type of energy gets increased during thunderstorm activity nearby. And actually, there's been a lot of thunderstorm activity in Europe. We see that here with our map, the flash map. And so there's a bunch of activity actually in this part of Europe. But Tomsk is like, again, you know, if we use, it's like way off in, you know, east, like central Eurasia, really. So it's not being affected by that, but there is some lightning data in this here, because here we have like our 6 days. We see this lightning that's come in recently. That was fairly close to Cumiana, Italy, so it did put some local atmospheric disturbance noise in there. But if we go up, we do see some disturbances in the Schumann resonances as well out of Cumiana that are not related to atmospheric disturbances. That's why I've done a tremendous amount of research into this. I've checked this stuff every single day religiously, so I'm able to make the differentiation between that. I've made a ton of videos on the channel, helping other people to learn how to distinguish between the two. But you see where my cursor is right there. That's actually our first weird disturbance to Schumann resonances that we see right now happening. This is a live data feed. And that's actually at a very high frequency. This is above 50 hertz. This right there is 50 hertz noise from the power grid. But we see some other disturbances in here too. We see some up there. We also see some right here. And we do see some further down right here with the other mode. So this is 14 hertz with mode 2. That's the foundational mode. Here we have mode 3, 20 hertz. That's that pre-earthquake zone. And so we're seeing some disturbances there as well, and also going into here. So they're very faint, these signals that we're seeing in Cumiana, but we are seeing some anomalous signals there. And we're going to look at the historic data for Cumiana, Italy that occurred before the seismic burst at Campi Flegrei back in mid-February of this year. So if the station going offline in Tomsk, Russia is not just some sort of random malfunction, but actually because of some power surge due to resonance amplification of natural earth energies, then it would seem that because these signals are quite a bit weaker, that it's much more localized closer to Tomsk. And therefore, maybe it's like Ring of Fire related if we're talking about a big earthquake, like a giant earthquake. Perhaps it's coming from like the Ring of Fire area. My intuition is kind of saying Japan, but I don't know. I'll talk about that more later. But that would then bleed off and the signals would be much more diminutive over in Cumiana, Italy, because of inverse square law and attenuation. But the fact that we're still picking up some signals here is also verification that something weird may be happening. So let's go through the historic data examples. There's quite a few that I want to show you so you can make up your own thoughts on what I'm presenting to you now in the present moment. But when we've seen these sort of things before, we've seen high magnitude earthquakes quickly following. So let's look through the historic data. And hi everyone, welcome to the live stream. If you're new here, I'm your host, geophysicist Stefan Burns. And that's what we look at on this channel. We examine Earth geologic events, geophysical events, space weather, solar activity, planetary resonances, and also cosmic forces. So we're also going to look at some of the current energetic factors as well. But first I want to look through the historic data. So to get that kind of put into context, here we have a graphic that shows how earthquakes can produce electromagnetic signals. And this is just like a very simplified graphic, okay? There's a lot of different things that can be fed into this, but if you have a fault that has a lot of stress, it can create a stress-induced current. This can be before and or during the earthquake. And you will have positive charge go to the surface, negative charge goes down below to the p-n junction, where all of a sudden there's an abundance of free electrons because you have minerals, geologic minerals transition from p-type semiconductors to n-type semiconductors, which are electron dominant. So this can create enhanced electric fields at high topographic points. So that could strengthen that vertical electric field gradient and the frequencies nested within, like the Schumann resonances. It can also create earthquake lights. And so earthquake lights, actual plasma coming up from depth from the surface because there's stress on a fault. And whether that's plasma perhaps coming from deeper in the core passing over a fault on its way up to the surface, or whether it's plasma being generated by the fault, a whole bunch of microfractures and slips generating these charge carriers which combine into a larger orb or just mass of plasma, or both or more factors. These are all things that we are still learning, but there seems to be a plasma component to this. But we have a rich history of electromagnetic observations in the ULF band, ELF band, VLF band, even like DC magnetic field pulsations on Earth's magnetic field overall, before high magnitude earthquakes. For example, 1964, before the magnitude 9.2 earthquake in Alaska, we actually saw changes in Earth's magnetic field, oscillations in Earth's magnetic field strength overall, not just specific frequencies, but Earth's magnetic field strength being measured in Alaska all the way down to California, measured these same micro pulsations on the total field strength. That's some old research going back to 64, but I met the guy who did some of that pioneering research, Sheldon Briner. He founded the company that I used to work for, and I met him just like, a few months before he passed away, unfortunately, in 2019. And the guy he discovered the Olmec heads. He was an eccentric geophysicist millionaire. He was a cool dude. So let us look at some of this historic data. Now we have some of this kind of context and understanding. Well, actually, I don't want to show that one. I want to show this one. This is the most significant one that I want to show first. This is before the magnitude 7.8 and 7.5 double earthquake sequence on February 6, 2023, Turkey, Syria. You know, hundreds of thousands, I think at least tens of thousands of people died. It was really, really unfortunate. Tons of infrastructure damage. There were warning signals from the Space Observing System. Unusual streams of energy were observed on February 2nd. Notice that range. This is 0 hertz. This is 40 hertz. We're looking at a spectrogram here, okay? We see these unusual energy signals appear there 4 days before. Here is when the earthquake occurred. That's the exact time right there of the magnitude 7.8. And check out that unusual burst of energy that occurred in the vertical electric field. Also, we see an echo of that there, and also a lower frequency echo as well. But really caught in between modes 2 and modes 4 there. So going from about 14 to 26 hertz, we see this energy stream that occurred directly during and up to 6 hours, I believe, afterwards, like 6 to 8 hours after that magnitude 7.8 earthquake. But look at the quality factor for these pre-earthquake signals, again, indicating resonance amplification, the system going like this, right? And when all of a sudden you get things to amplify in the resonance, that's when things can then break. We had mode 3 at 20 hertz go up to 250. And mode 4 went up to 59 there. You notice that mode 2 only went up to 1370, like 13.70, and then mode 1 went to 10.70 for the quality factor, indicating again resonance amplification. And if we go back one more time to what we have right now with our latest data that has been cut off, these numbers are all in the 100s, much, much, much higher than what we saw before the magnitude 7.8 earthquake in Turkey with those pre-earthquake warning signals. So again, this could be just some sort of malfunction of the equipment. That's a possibility we can't ignore, but we also can't ignore the possibility that this was some signal that came in and immediately overloaded the equipment, and this is all we got as it relates to a warning signal. And if that's the case, then this is indicating something really big is about to happen. And we hope that's not the case. But it's my responsibility and duty as someone that understands this and has a public channel which talks about this to do this public announcement right now for all of you around the world. Let's continue looking through our historic examples. We will go to what happened on February 22nd, 2024. This is just a quick example, but we have it. Here we have more anomalous signals in the Schumann resonances. You see them really nicely there, but we also kind of have some scattered signals here as well. It's kind of similar to what we're seeing right now. And we are looking at the quality factor here. You see that mode 2 went up to 70. It's right in that zone. See that stream right there as well. That is also an anomalous signal. And this was on, we got this on the 22nd of February. We had 2 X-class flares actually right around this time frame from the sun, which are the strongest type of solar flares that you can have. You have different categorizations, and X-class flare is the highest level. So that's also unusual. And then on the 23rd of February, there was a magnitude 6.3 earthquake. And going from February 15th to March 2nd, that was the only magnitude 6 plus earthquake that occurred. So everything else is magnitude 5 or lower, and these anomalous signals appeared 24 hours before that magnitude 6.3. It is worth noting that on March 3rd of 2024, there was a magnitude 6.8 in the Marquarrie Islands, actually where we just recently had a 6.8 earthquake just like a couple days ago. But this was on the 22nd of February, and then March 3rd is like it's more than a week away from these signals appearing. And we had that 6.3 that occurred 24 hours after this, like within 24 hours. So I think that's another clear example of these pre-earthquake signals giving us a heads up for a high magnitude earthquake. And we have more examples. Let's go and check out some of these other examples that we have. This one is very, very striking. We see again these anomalous signals in our background vertical electric field observed out of the Space Observing System, Tomsk, Russia. And again, it's in that zone of mode 2 to mode 5, which is about 14 to 33 hertz, even going to a higher frequency there. So very unusual signal duration for 13 hours. And as I mentioned, last time we saw these signals was before that Turkey-Syria quake, as when I created this graphic. This was on November 29th, 2024. And if we go forward to the next graphic in this sequence here, we see our Q factors. Mode 2, 14 hertz, went up to 120. Again, normal range is like 10 to 15 or so. Mode 3 went to 190. And then mode 4 there, 26 hertz, went up to 49. And this again, November 29th, 2024. And on December 5th, 2024, that is when we had the magnitude 7.0 earthquake off the western coast of California up near Pretoria. And that was the biggest earthquake. That was a big earthquake, and the biggest earthquake that California has seen in a while. So we have also observed these anomalous, what are often pre-earthquake signals less than a week before that magnitude 7 earthquake in California. They seem to be connected together. This is for pre-earthquake signals out of Cumiana, Italy. And you can see how really intense they can get. And this is going from February 9th all the way to February 13th. Let me step off to the side. And you'll notice that we started to get these anomalous signals there in that pre-earthquake zone, but even higher frequencies, 9th, 10th. We see them kind of faint there on the 13th. They really popped off on the 13th late at night universal time. And well, if I switch over here, you'll see we had a seismic burst at Campi Flegrei. And this data is set for February 13th and 19th. You'll notice most of these are yellow, which was February 15th. So 2 days after we got those anomalous signals in Cumiana, Italy, we had this seismic burst at Campi Flegrei, the biggest that we had since April and May of 2024. And the seismic activity at Campi Flegrei has been going exponential for a couple decades now. So this is a significant event. It was like nearly 1,000 earthquakes. And so those pre-earthquake signals that I just showed you seem, and because Cumiana, Italy is not that far away from Campi Flegrei, Italy, right? The Phlegreian Fields, Naples, not that far away. They're pretty close together in the grand scheme. These pre-earthquake signals seem to have heralded the fact that there was about to be a seismic burst at Campi Flegrei, and lo and behold, there was. And I reported that on the channel quite extensively, as some of you will definitely remember. This is data out of Japan. They have a really good pre-earthquake seismic network in Japan, observing these Schumann resonances. And they've picked up signals in Japan. They've picked up signals from earthquakes in Taiwan. And here's a good example of like what you can expect. So this is like a normal power spectral density plot of the background electromagnetic field. And we see these little peaks there in the intensity. Those are the Schumann resonances, mode 1, mode 2. You see them go up. But before an earthquake, we see that mode 4 there went up dramatically in the intensity overall. And you can see that on the spectrogram. All of a sudden you get this burst there at that mode 4 frequency, about again 25, 26 hertz. So some of these precursor effects, lower ionospheric height and conductivity changes often precede large magnitude land earthquakes. Massive telluric currents in the crust due to lithospheric stress create electromagnetic waves, and only the lowest frequency of those waves will reach the surface before attenuating. Energy in the 20 to 30 hertz range sometimes has anomalous significant power increases preceding an earthquake. The stronger the earthquake, the further in advance these earthquake precursor signals may occur. For example, the Chi earthquake, 1999, Taiwan. I believe that's Taiwan, maybe it's China. I think it was Taiwan. Either way, 1999 Chi earthquake, big earthquake, that had anomalous electromagnetic signals that were being observed 6 weeks in advance across a variety of frequencies. And then significant frequency deviations from the normal can occur in the Schumann resonances, especially at mode 4, 25 hertz. So you also see a frequency shift. We often see these ionospheric disturbances and conductivity changes to the atmosphere before earthquakes. We see a disturbed profile there with conductivity, a regular profile, significant enhancements in the conductivity, helps these rock circuits to connect. You need a flow of charge to connect. You need a circuit to have conductivity throughout for it to actually form. If you don't have a complete circuit, you just have potentials that build up. So if all of a sudden you get an increase in conductivity that allows that circuit closure, then you can have that flow of charge, which will then generate electromagnetic signals. So they specifically noticed with one of these studies is that the land earthquakes had these sort of anomalies show up really readily because it was able to go directly from the lithosphere out into the air. And once some of these signals are out in the air, they can propagate out really widely. Whereas if the earthquake is underneath the ocean's so conductive, it absorbs a lot of this electromagnetic energy unless A, the earthquake is very large, and B, it's at a very shallow depth. And so it doesn't have to go through that much lithosphere and also not that much ocean water, which again is very conductive and will absorb any of these signals that it receives. So it seems, and with Turkey, Syria, if I go back to that graphic, that was not an earthquake that was out at ocean, like out at sea. There was no water on top of that. That occurred over land, and so we saw these signals appear before and during. There was very little attenuation. So these pre-earthquake signals are most common from land-based earthquakes. That is what the evidence suggests. Now let's look at our current factors because, is this a pre-earthquake signal? Is this just some random data fluke, or is this from some sort of outside factor, right? Let's check it out. We have our cosmic rays. We'll start there. We have our cosmic rays provided by the University of Oulu. Oulu. I don't know how to say that. I'm sorry. OULU. And I believe this is Northern Europe. And so we see our cosmic ray intensity has basically been flat here for 24 hours. And let me really step off to the side here. We see it's been flat here for 24 hours. We see that our 30-day look has basically been flat, a little bit of a trending up after that geomagnetic storm that occurred. But just a recent drop from the G1 storm that we've been in for a long duration. We are just coming out of a G1 geomagnetic storm. And we see our cosmic ray intensity here is also depressed because we are in solar maximum versus how it normally is during solar minimum when you get a lot more cosmic rays coming in because the heliosphere of the sun is weaker during solar minimum. It's strongest during solar maximum. So there's nothing in the cosmic ray data, to put it quite simply, that suggests that this is a factor as it relates to what we're seeing with these anomalous signals in the Schumann resonances. Next, we can go to our real-time solar wind. And we see here this G1 geomagnetic storm that was caused by a coronal hole high-speed stream. We see that the solar wind velocity went anomalously high. Maybe not anomalously high, but it went very high, nearly 800, actually even to 800 and beyond kilometers per second. And the density got very low. We've been talking about this on the channel. It seems that big earthquakes, the biggest earthquakes, giant earthquakes, magnitude 8+, it seems that they occur most often when solar wind density is low. If there's coronal holes on the sun in that geoeffective position, these giant earthquakes usually will have a coronal hole, a big one, in that geoeffective position. The solar wind density will be low. That at least was the case for the 2011 earthquake in Japan, the magnitude 9.1. It happened right when there was a coronal hole high-speed stream impact, and the solar wind density was super, super low, under 1 particle per cubic centimeter. And so we are in those conditions now, and we had that 7.4 yesterday. So that occurred during these sort of conditions, and we're still in those conditions right now. So that is the current space weather that's active. And on that note, let us look at these coronal holes that have been rotating by, because these are loaders of energy into the Earth. And there's a wealth of research out there talking about the connection between coronal holes, especially big coronal holes like this. This is like the largest that we had seen up to this point in like 10 years. Definitely weird also during solar maximum. They occur, and if they keep occurring and loading the Earth with energy over and over and over, 5, 6, 7, 8 rotations, that seems to have a loading effect on the Earth. And we often see those dynamics right before the biggest earthquakes, magnitude 8+ earthquakes. So let me go back to the beginning one more time, because you also see up here our global seismic activity. And you'll see that as this coronal hole first started to appear, that's when all of a sudden our seismic activity started popping off. I put out that earthquake watch back on March 24th. We've been in that zone of heightened seismic activity since now for 6 weeks. Whereas you see here before, it was only low to moderate activity. And then since then, earthquake activity has picked up dramatically. Eventually this will all end, but we are still in that earthquake watch, because if I zoom forward here, you'll see rotation number 8 of that huge coronal hole. We just got through that. There's that big daddy right there. Not only in the southern hemisphere, but also up top. And that is going to be very likely appearing for a rotation number 9. And that should be geoeffective right in this position here on May 17th, the same day as the Uranus-Cazimi. Also the same day we have some really significant heliocentric planetary geometry. Every single planet in the solar system is in a geometric relationship with each other on May 17th. So that seems to be a significant date. But we're seeing these pre-earthquake signals now. And this is rotation 8 right there. What we have coming up soon is rotation number 9. In fact, and so that's the 9th time it'll have loaded energy up. If it survives this far side transit, I think it's very likely to do so because it's been so large. It's exactly opposite this sunspot group right there, in fact. They are exactly 100 degrees opposite on the sun. So if we look at our most recent SDO imagery, this is also something to be aware of, because this sunspot group is looking very significant. It's quite big, and it's getting right into the strike zone at this moment in time, and it has been waking up. So it's starting to flare with low C-class activity. But we have this big sunspot group right here just now entering into the Earth bullseye strike zone, and the magnetic polarities on this are very, very strong. So let us look at that really quick, just a short detour, but we do have this also as an influence. And to go further on that, other than this sunspot group, you'll notice that there's really no other sunspots on the sun. There's very few. I mean, you have this guy right there. You have a new sunspot group, it seems, forming right there, kind of pushing out. But we also see this inverse relationship between sunspot numbers and earthquake activity. Global seismic activity, overall energy release from earthquakes seems to definitely, there's a really strong inverse relationship that spikes up dramatically when sunspot numbers go down dramatically. And so we were seeing that because right now sunspots are under 50, and we just had that magnitude 7.4. And so that's the biggest earthquake that we've had since the magnitude 7.7 in Myanmar, Burma, which also was exactly when we had a sunspot drop below 50. Actually went right to 50. So we have this guy as well. We have a very low sunspots, but we have a big flare potential, like solar storm potential. If this decides to launch something our way, it could be really significant because you see how strong the magnetic field polarities are. Really strong positive polarities there. These negative polarities have been strengthening over the past 48 hours, so it's looking quite significant. So these are all the things I wanted to bring to your attention as it relates to current conditions. We have this G1 storm that just wrapped up. Cosmic rays do not seem to be an influence, and there's no active solar storm impact right now. There haven't been any solar flares of significance, so we can rule that out. It seems to be an in situ Earth signal. Here we have our global seismic activity for the past 90 days, updated for today. And so you'll see that 7.4 there raised the activity to very, very high yesterday. And just in general, you see that we were in fairly quiet activity before this global seismic burst started. That's lasted now about 6 weeks. Again, this is 3 months of data. This is the magnitude 7.6 southwest of the Cayman Islands. It was just a temporary, it's a big earthquake, 7.6. But it was just like one day spike and then activity went right back to baseline. It looked like this for actually most of January as well. There was one high magnitude earthquake also beginning of January, but big change in what's been occurring so far for 2025. And I'm not sure if he has a graphic specifically for this does it right here. Here we have the graphic for all of 2025. And so you see that earlier activity in January a little bit, but in general, look how quiet it was. Maybe I can zoom in a bit here for you. It might be a little difficult, but let's see if we can do this. That's better. Yeah, there we go. So yeah, this is the global seismic burst that we're in right now. It seems that it's because of these coronal hole high-speed streams. We've had that loading from coronal holes. The big one 8 times now, though it's been growing each time. So it's only been rotation number 7 and 8 where it's been really large. But we have other coronal holes on the sun as well that have been loading the Earth because again, for example, here's the one that rotation number 8, but we just had these ones impact us with their high-speed streams. So we're actually being loaded with this energy more than every 28 days. That's the normal solar rotation period, about 28 days. We're going to see this coronal hole every single time. But you see that this guy there is actually just following up about a week, maybe like a week later, not even that, if you go from here to there. So we're being buffeted by these high-speed streams really, really often right now. And those are exactly the conditions that we see before, like the highest magnitude earthquakes, magnitude 8+. We haven't had a magnitude 8+ earthquake in 3.5 years. Typically, we get one every year. They do seem to cluster a little bit, but in general, we get a magnitude 8+ at least once a year. It's been 3.5 years. So we are, you could say, overdue on the global scale. The last thing I want to show you is that we have our Schumann resonances out of Hungary as well. And we do see this big increase in the power here. I'm just doing this for completionist sake. This was from that local atmospheric activity in Europe. So this is not anomalous signals out of for any sort of earthquake or anything. That right there is a power surge from all the atmospheric activity. Because actually, if you go over here, you can see that these storms are still slamming Europe. They have diminished a little bit, but tons of crazy hail in France, like hailstorms. So really significant thunderstorm activity across Europe that is responsible for this increase in the Schumann resonances, which we actually will have to pull up now that it is midnight universal time. We'll have to pull it up by going into their database here. So here's the entire data. And now actually that we have the most recent, perhaps we can see some anomalous signals in here. And we do see a couple little odd things. It's hard to say. This data is kind of low resolution. I've been to this geophysical observatory in Sopron, Hungary. The people there are great. I just wish that their data output was a higher resolution like it is for the space observing system. But we do see perhaps some little anomalous bits of power increase kind of spread out after that atmospheric burst. But we also see that kind of noise spread out typically throughout the data. So we have seen global intensity signals in the data out of Hungary, but our space observing system seems to be the highest quality as it relates to these sort of pre-earthquake signals. And also tracking the quality factor is really, really key. And these values are literally off the charts. Like, it's very possible that this resonance amplification was so strong that it knocked it offline. And so, oh, not that. Google Earth. Yeah, let's go to Google Earth. I just want to show you where these places are. And for everyone that's new here, hello and welcome. I'm your host, geophysicist, space weatherman Stefan Burns, just a guy trying to understand what's happening here on this planet. I find this interesting. If I can do my duty to help people prepare, perhaps, then that's a good thing. No, the world is not going to end, but earthquakes are serious business. For anyone that's been in a big earthquake, you understand it. So I'm not a doomer, but just someone who really wants to effectively give people heads up on potential Earth things that are actually occurring, like reality. We're talking about reality here. I'm kind of thinking Japan. I don't, again, we hope nothing happens. I don't want anything to happen, and nothing could happen. There's no guarantee that the signals that we're seeing out of Tomsk, Russia, are in fact even true observations. Maybe the data was just some sort of error with the observatory, right? That's very possible. But we saw that the data out of Cumiana, Italy, which is nestled up right there below the Alps, was weaker than the initial signals that we've seen out of Tomsk, Russia. And we know that Japan is like locked and loaded. And just an interesting thing, not saying I believe this or that this is the case, but just an interesting thing to keep your mind open to. Again, not saying that this is the case. It's just, I'm just presenting an interesting thing. Turkey, right before this magnitude 7. This is what a lot of people in Turkey believe this, okay? Let me say that. A lot of people in Turkey believe this. Right before those magnitude 7.8 and 7.5 earthquakes occurred in Turkey, Turkey was engaging in this sort of like confrontation about letting people into NATO because of the Ukraine war and all this stuff. And so some people in Turkey, and also some people just in general, think that those earthquakes were created and they weren't natural. And it was the United States basically having leverage over Turkey, saying, hey, if you're not going to abide by our will, boom, we're going to create an earthquake. Now, whether we have that technology or not, I don't know. We know that there are things that are similar to that sort of technology, but whether it's true or not, that's up for you to decide and research into. There have been, for example, whistleblowers for the Antarctica. I don't know if I believe them or not, but we do have people talking about it. But right now we have Japan flexing its muscles against the United States in this trade war and saying, hey, we got $1 trillion in US bonds, we may sell them. That's a card that we have. So again, this is just I'm not saying I believe this 100%. I'm just presenting that it's interesting. It's interesting. That's all I will say with that. Make up your own mind, do your own research. That is all we can do. That is all we can do. So that is it for this live stream. I'll keep you up to date every step of the way. I guess the last thing I can do actually is I can refresh our data feed for the Schumann resonances, see if anything has changed since I started. And we'll do that on the capture here. So I'll just, I already did it, but I'll show you again. Refreshing this, nothing new is pulling up. So it looks like we're still offline for our data for the Schumann resonances out of Tomsk, Russia. We go to Cumiana, we can refresh it one more time during our live stream, see what the latest data is, see if there's any new kind of anomalous signals. And that does seem to be the most significant one there. But in general, just a little bit of kind of some noise. Like, do you see that little thing right there? You know, there's just oddities. They're not big by any mean. This line right there is an oddity. And we saw, and also here, some of these signals right here. Do you see these right there? Those are oddities, not the biggest ones. It seems that whatever this source is, if this is a source generating these pre-earthquake signals, these anomalous electromagnetic emissions, it seems that it's closer to Tomsk, Russia than it is Cumiana, Italy. And so we get the biggest earthquakes with the Ring of Fire typically. So that's kind of where my intuition is guiding me. But again, I hope I'm wrong. I hope that this is nothing, and that in a few days we forget about this and nothing actually occurs. But we are in this global seismic burst right now. We have the space weather conditions for it from these coronal hole high-speed streams. We're overdue for a magnitude 8+ earthquake because it's been 3.5 years. Typically we get one a year. So you line all the factors up and things are looking odd. We got a full moon coming up on the 12th of May. And that light, and there's some also evidence that squares are the strongest influence as well as it relates to earthquakes. And right now the moon is square the sun and also Mars. So we have that dynamic at play right now as well. So it is a quarter moon right now. It's a waxing gibbous quarter moon. So should be waxing gibbous quarter moon. Yeah, it's right around there. So That is your update. Again, I've been your host, Stefan Burns. Thank you all so much for watching. I'll keep you up to date, so please subscribe to the channel. This is my job. I consider myself like on call with this, so whether it's early, late, whatever, I am like tracking this stuff religiously. So just doing my best to understand what's happening on the Earth from a neutral, independent perspective. You know, I look at everything with an open mind. But I don't just ape into any like belief system or philosophy. I really just want to be full bandwidth and take things in, and then, you know, distill the truth as best I can, and then present that to you. So that is what I do here. So again, if you like that, please subscribe, smash that like button, help this channel grow, share this with some people, and I'll see you all in a future update. Sending you lots of love and light, and wishing all of you well. Please take care of yourselves and have a great day.